Hey, what's up, Algebra 1? I'm going to go ahead and make a three-part series of your final review. During this time, whenever I'm able to use Desmos to show you how to do answers, I will be going to Desmos and showing you how to work it. Desmos will be allowed to be used on your guys' test, okay? So let's look at Chapter 5, Unit 5, Polynomial Expressions. The first thing we need to go ahead and look at are rules of exponents. So let's go ahead and review those rules of exponents real quick. So if I have multiplication, so if I have AM times AN, our rule is the following: AM plus N. Okay, you're going to add your exponents. When we divide, so if we have A to the M divided by A to the N, we're going to subtract our exponents. And finally, our third rule is if we have A to the M and then we raise that to the N power. So if we have a power to a power, we are going to multiply our exponents. So let's look at these two examples that they gave us. The first example, as you can tell, we are dividing. So we are going to follow this rule. When we divide, we are going to subtract our exponents. So we have 4/7 minus 2/7. Looky there, we already have common denominators here. We have common sevens, which that's good. That makes our life so much easier. So we're going to subtract the top and get 2, and we do nothing to the bottom. So we end up with S to the 2/7. So let's go ahead and look at our examples. Carol answered S to the 2/7 because she thought the exponents should be divided. Not quite. Wanda answered S to the 6/7 because she thought the exponents should be added. Obviously, we know that's not true because it needs to be subtracted. Margot answered S to the 2/7 because she thought the exponents should be subtracted. Boom. Good work, Margot. Let's look at our next example. It's pretty much we're going to be multiplying. So we are going to follow this rule right here. When we multiply, we add our exponents. So our trusty person this time is Alan. Alan knows that when we multiply, we need to add our exponents. Okay. So know those rules of exponents. The questions on the final, once again, are multiple choice, and they're pretty straightforward, just like these examples. Okay. Let's go ahead and check out the next set of examples. We want to simplify, so we're multiplying here. So the method I showed you back in the day was a tic-tac-toe method. So we're going to go ahead and make a tic-tac-toe. At the top, we're going to put our first polynomial, which is x squared minus 2x minus 3. And then on the other side, we're going to put our other polynomial, 4x minus 5. And we're going to go ahead and multiply, okay? Remember, when we multiply, we add our exponents, just like our previous examples. So 4x and x squared is going to be 4. X1 and x2 make x3. 4 and negative 2 make negative 8. X1 and x1 make x2, so x times x is x squared. 4 times negative 3 is negative 12x. Now let's go to the bottom. We're going to multiply everything by negative 5 this time. So we have negative 5x squared. A negative and a negative make a positive 10x. And then finally, a negative and a negative make a positive 15. Okay. Those last two, we had two negatives, so that's why it became a positive. Now what we're going to do is just collect like terms. 4x, we're just focusing on the red. 4x cubed has no one to collect with. These guys are common because they're both x squares. So negative 8 and negative 5 become negative 13 x squared. These both have x's. So negative 12 and a positive 10 become a negative 2x. And then this 15 has no one to go with it. Let's do one more example. Go ahead and make your tic-tac-toe grid. The top is going to be x squared minus 4x minus 1. And the side's going to be 2x minus 1. Let's go ahead and multiply. So this box right here is going to be 2x times x squared. So 2 times 1, 2. x1 and x2 are going to be x3. The next one, we have negative 4 and the 2 make negative 8. x1 times x1 is x2. And then finally, negative 1 times 2x is negative 2x. Let's go to the bottom. We get a negative x squared. Negative 1 and negative 4 gives me a positive 4x, a negative and a negative. And negative 1 times negative 1 is going to give me a positive 1. 2x cubed has no one to collect with. We have some x squares here. So that's going to become negative 9x squared. We have some x's here, which is going to become positive 2x. And then finally that positive 1. Okay, let's check out the next set of questions. Select two expressions that are equivalent to x. There is a typo in this particular one. Only one of them actually equals x. So x to the 1/3 times x cubed. We're going to add our exponents. So 1/3 plus 3, which we can go ahead and put that over 1. We need common denominators of a 3. So we need to times this guy by 3. So we end up with 1 plus 9 over 3, which is 10/3. Does that give me x to the 1 power? No, that gives me x to the 10/3. Okay, so this one's a no. Okay, when we divide, we subtract our exponents. So negative 1/3 minus 1/3 is negative 2/3. Once again, that does not equal 1. Boom. Okay, power to a power. If you look above, I wrote all those powers in the previous example. We multiply these. So 3 times 1/3 is 3 over 3, which is 1. There's our answer. Let's go ahead and look at number 4 now. Number 4 is to simplify, okay? We're going to simplify these guys. So we have 5, the 5th root of 243. So let's go ahead and factor tree this. So 243 is 3 and 81. 3 is a prime number, circle it. Let's take 81 further. 3 and 27. Circle that 3. Let's take that 27 further. 3 to the 9. 3 times 9. And then finally 9 is 3 times 3. We're looking for, so since this number right here is a 5, we're looking for the same number mentioned 5 times. So 3 is mentioned 5 times. 1, 2, 3, 4, 5. So in this particular jail, remember my analogy of algorithms, you need to have the same number mentioned 5 times. So 3 is mentioned 5 times. So they get to escape because there are 5 of them. But per usually, only 1 survives. Let's do 16. 2 and 8. 2 is a prime number. 2 and 4. 2 is a prime number. 2 and 2. Both of these are prime numbers. This time, our root is a 4. So in this particular algorithm, you need the number mentioned 4 times. Okay, so we have 1, 2, 3, 4. So they all get to escape, but they only one survives. Okay, and let's go ahead and check out number 6. Did I? Yep, number 4 is not on there. Let me get that on there real quick, guys. Sorry. Okay, number 6. Once again, we're going to do the tic-tac-toe method with this guy. But this time, we only need to just make a normal tic-tac-toe grid. At the top, we have 3x plus 5. And then on the sides, we have 2x minus 4. Let's go ahead and multiply these. We get 6, 3 times 2. X times x is x squared. 2x times 5 is 10x. I just like to put those symbols there. Negative 4 times 3 is negative 12x. And then finally, negative 4 and a positive 5 is negative 20. Let's go ahead and collect like terms now. 6x squared has nobody to collect with. Negative 12 and a positive 10 is then negative 2x. And then finally, negative 20. And then our next one, let's do it once again. Make your tic-tac-toe. We have x plus 6, 3x minus 10. Three x times x, we get 3x squared. 3x times 6, 18x. Negative 10 times x, negative 10x. Negative 10 times 6, negative 60. Let's go ahead and collect like terms now. The 3x squared has nobody to go with. These guys get collected to negative 10 plus 18 is a positive 8x. And then the negative 60 doesn't have anything to go with it. Okay, let me download the study guide real quick so I can get number 5 in there, number 4 in there for you guys. So give me a second. Okay, let's check out number 4. Let me zoom in. Okay, with number 4, what we're going to be doing is just collecting like terms. Okay, we have an addition sign in the middle, so we're just going to add these common terms. So we have a 4x squared. It's going to go with the negative 2x squared. 4 minus 2 is 2x squared. The plus x doesn't have an x term in the other parentheses. So we're just going to go ahead and rewrite that. And then finally, negative 3 and the positive 7 make a positive 4. That's it. Next example, 5x squared and plus negative 3x squared is going to give me a 2x squared. The 3x doesn't have anybody common with it, so we're just going to rewrite it. Negative 4 and a positive 5 make a positive 1. Okay, that is it for Unit 5, Polynomial Expressions. Like I said, this is going to be a 3-part series. Go ahead and close this video, and your next video should be ready to go for you. Unit 6, Quadratic Equations and Functions.